Well, welcome everyone. We're going to be talking about Django and channels. And so if you don't know what either of those words mean, I'll try and at least explain a few of them along the way, especially when it comes to channels, async, and WebSockets. I want to thank Peter for helping me put together this presentation. This work that we're going to show you is based on a Ship It Day project that we did at the beginning of this year for 6 Feet Up. And so those who aren't familiar with Ship It Days, you can go to our blog and kind of find out more about that. But it's like a 24-hour day of innovation where you get to like scratch an itch and build something cool and solve some kind of problem. And so one of the problems we chose was to add Discord support to our Loudswarm product. So if you're not familiar, like 6FIP developed a virtual event platform called Loudswarm. Let me mute this here real quick. Called Loudswarm so that we could actually produce awesome online virtual events for our conferences like Python WebConf and things like that. So that's what this is all about, why we came to using Django channels so we could actually add asynchronous WebSocket support for our product, which already had WebSocket support, but I'll talk about that here in a minute. So this is kind of leading up to the backstory. The backstory about Django and channels is that the web is mostly synchronous. And I'll talk a bit about what that means for Django and its requests and responses. And Peter, at any point in time, please interrupt me if I say things that are incorrect, because you are my source of truth and checking all my facts as we go along. But with Django being mostly synchronous, because it was kind of born before the concept of asynchronous and WebSockets and the technology that really drives a lot of the highly interactive sites of today. But Django is kind of moving into the modern age. As of Django 3.0, they included the ability to start having asynchronous components hosted right alongside the standard Django synchronous components. Each subsequent release of Django in the 3 series right now is adding in additional asynchronous support. So for example, 3.0 was routing, 3.1 was views, 3.2, Peter, correct me if I'm wrong on this one. I think we were supposed to get ORM, but it may not happen.
Yeah,
Is
it's
that
probably
correct?
delayed till 4. Yeah.
Yeah. Okay. So that basically we're building all the other bits of asynchronous into the Django platform that didn't exist. But luckily with Django 3, we had the ability to really start doing some interesting things with asynchronous. But channels actually enabled that before we got to Django 3. So if we talk about, this is the standard Django request and response model. So this is the synchronous way that Django handles a request coming in from a web browser. So if you look at this like stack, we've got our middleware and then our view function and then our requests and our responses. So that's just how Django handles any request coming in for a page. Is it you'd make a request from your browser, it would go through all the various middlewares looking to authenticate you, making sure you got a session and all other kind of things that go along with that. It hits the view code, and behind the scenes, it'll go look for a model, it'll go look for a template, and then it'll render a response and actually passing it back through that same middleware again, back to your browser. So you have that's starts here, ends there, and that's kind of the end of the story. That is the request and response loop from a standard synchronous Django application point of view. What we really want to talk about though is how do we make this more bidirectional? How do we actually take and allow for like long running connections from the browser to the application? So the previous thing I showed was the synchronous Django event, request response loop. That is part of the spec that is what Django has been built on, called WSGI, the WSGI, the Web Service Gateway Interface. That is a synchronous spec, which basically tells us how a Python application can be hosted and how you can kind of chain them together and all those kinds of things. But it was very much a synchronous specification for how to deliver a web application. If we want to change that around and actually be able to deliver asynchronous applications where we can use things like WebSockets or MQTT or long like connections that are just open for a long time, as opposed to like the event loop, which is like it starts here at the request, ends the response, and that's the end. It's done and it's over. We need to move into the ASGI, so the asynchronous gateway interface, to make these things bidirectional. So if you're familiar with Django, and when you deploy a Django application, you're typically deploying it and pointing your application to that wsgi.py file. As of Django 3, they've added in an asgi.py file in the config directory for your project, for your Django project, and you can actually host and route application requests to an asynchronous backend in addition to the synchronous backend. So all the standard synchronous stuff of Django is still there, still running, and still available. Actually, it's kind of the default mode of operation for Django still. But we've added in, as of Django 3, the ability to now use ASGI and do routes to asynchronous type workloads. And I'm going to show you a little more about that. But if you really want to kind of go in depth, if this topic is of interest to you, Aaron, he has an awesome blog post here. He wrote a book on Python a couple years ago, or not Python, Django a couple years ago. And he has really done a good job of describing some of these ASGI changes to Django 3. And that's just one of the many posts. And then there's actually a good YouTube video here that introduces ASGI as a protocol. So if you kind of want to deep dive on the asynchronous part of the ASGI protocol, it's not specific to Django necessarily, but Django now uses it as part of the asynchronous framework to deliver your applications. So let's talk about the asynchronous part of this. We're kind of done talking about all the synchronous stuff. What I really care about here right now is talking about the asynchronous application of using WebSockets. So let's actually see a WebSocket in action. I'm going to go to ploneconf.loudswarm.com and I will log in. And I'm going to open up the networks toolbar here. Yep. Okay. So when I load this next page, so I'm in a web application right now. Get this out of the way. It's basically our event platform. We use WebSockets, but I've not touched a WebSocket yet. Well, maybe I have, but you aren't really seeing it. What we use WebSockets for in our application is sending real-time chat from Slack, and we actually support Discord now, but I'm going to talk about that. We're going to talk about Slack first. If I look at this specific session, here we go. And you can see over here, we've got our Slack chat going on. And I'm going to pull this open. Oh, it's actually running the video. Let me filter this out. Here we go. I'm going to filter this just to WebSockets. I'm going to, there we go. What happened when I loaded this page is that the Slack chat box on the page established a WebSocket connection back to our the main server hosting the application itself. So you can see the URL is like /ws. So we have a route in our application that says handle anything that's like /ws by handing it off to the asynchronous WebSocket consumer of our application. So on that request, it hits, and now if let's see if I can actually make it do something interesting. I'm going to go into the PloneConf channel. This is actually linked up to Conf 2020 track 1. And I'm going to spam those poor folks over there who weren't expecting this. Hello from IndyPy. And so we should see, boom, there we go. We see hello from IndyPy. That showed up in real time on the page. I didn't have to reload the page. And you also notice there wasn't a new request that happened on, oh, thank you, Chrissy. It's like kind of you to play along nicely this time, I hope. I'll tell a story about that later when she didn't play along so nicely. But you'll notice that we didn't actually get a new connection to the server. There's one long-running connection to the server that is continually receiving data to get new messages in from that. So each message that comes in over here just comes down that pre-opened pipe that's sitting and like waiting for new messages to come, and it's bi-directional. The application from the web browser can send content and data down that pipe, and the application, since it's been opened up to the browser, can do the reverse. It can actually send content back the other way. As you can see right here, there's Chrissy's message that she just sent there saying, well, hello. And that just came in not as a web request, but as a web socket. And so it's just a specific protocol for doing this bi-directional messaging. The browser initiates the request to the server. The server is like, cool, holds it open. And as long as I'm on this page, data can flow both ways down that pipe. As opposed to what you normally expect is you put a URL in the browser bar, the browser makes a request to the server, and it sends back a request, and then we're done. Like there's no more communication happening typically after that point. So that is really what the essence of a WebSocket is when I'm talking about a WebSocket. So putting that into action right there. That's all well and good. I really enjoy that. Now, that was all possible because Slack has an API or developer integration that allows me to send webhooks back to our application. So on each chat message, Slack is sending me a message to my app, and in my app in turn says, okay, send this down the WebSocket to anybody who's connected. So there could be 1,000 people connected to our application. All 1,000 would get that message simultaneously, all as part of like the WebSocket protocol. Now, that's all happening because of channels. And the first part of channels, there's kind of three main parts to channels of this asynchronous framework. And so channels is a add-on to Django. So you would install it separate from just installing the Django egg. It leverages the asynchronous parts of Django currently because we're in 3.0 land or 3.1 land of Django itself. But the main piece we're seeing, the thing you just saw all work, is this consumers. This is what we think about when we talk about channels and the WebSocket specifically. Let me open this up real quick. That's actually how Django can send messages down the channel and receive messages from the channel is through this consumer. Now, the second part of channels is channel layers. That's basically a layer underneath that allows us to have some kind of messaging between our code and those various channels. You could have messaging come. You could be running a cluster of multiple Django applications, and you would want all of them to be able to send the messages out their channels in a nice coordinated way. And so the channel layers give us a way to basically send messages to a specific channel and have a consumer handle that message for us, and then do vice versa, like kind of a persistence layer for new messages coming in and then having them be handled. The
This is back.
last,
This is
what's
backed
that?
by Redis, by the way.
Yeah, in our case is Redis. There's other channel layers drivers, aren't there? I thought there's one else.
It's mostly Redis at this point. I don't think the other ones have been developed that much.
Okay, so yeah, we are in our case we are using leveraging Redis for our channel layer in this example as well. The third part of channels, which is fairly new, is background workers, which allows us to do some like lightweight background tasks, kind of like if you've ever used Celery as a task runner inside of your Django applications. You can think of it like Celery, but there's going to be some constraints, and I'll talk about those here in a minute. But let's look at an example of what we just saw, like that chat message coming into our Slack and then going out to the web browser. So this is an example of a WebSocket consumer. This is a JSON WebSocket consumer, so it's going to send data back and forth serialized as JSON to the browser and expects JSON in return. They're going to be basically some methods you'll define on your consumer that will be accept and or connect and disconnect. Those will be events that happen as new browsers connect and as browsers go away, allow you to do some kind of operations against them. And then if you look at this, we got a receive. So anytime messages come down our channel, this gives us the ability to handle that message coming down our channel. And we can also send messages to our consumers by making another method on our consumer. Like say we had a message for a send message method on our consumer. If I sent a send message, message to our channels consumer layer or a channel layer, this consumer could pick it up and it would know how to handle it based on the name of that method. So there's a little bit of mapping of like method name to channel messages for the handling of those messages. So that's again very much the standard use case for Django channels and Django consumers. Well, channel consumers inside of this example here. Now, how does this all get routed? I mentioned before that I had /ws as part of my URL. Actually, we looked at it right here. You can see the /ws route. Just like you configure other routes inside of Django, you would configure routes to handle WebSockets. In our case, we're still using, this is an example straight out of channels 2. Channels 3 has changed this up a little bit where you would actually have to define your HTTP protocol routes. But in our case, we're still using a Django 2 for this one because 3 had just come out as we had done a lot of this work. So I have in here for anything that is a WebSocket protocol, I'm going to load up these URLs patterns for handling anything that's a WebSocket. So I can actually register multiple URL router patterns to handle WS can go to this app and WS2 can go to that app. And you can do just like you do with normal Django views is you can route multiple URL patterns to different consumers inside of your application. And in addition to the HTTP protocol and the WebSocket protocol, you can also establish channel protocols. So if you send messages to a channel inside your application, so for example, in our case, we're registering Discord send as a channel route, we can then call our Discord sender to handle that message coming off of our channel layers. So we'll talk about that again for sending messages. So everything I've talked about here so far is still very driven by the fact someone has either connected or sent a message or wanted to talk to us or we wanted to talk to them. but the initiator is happening external to the consumers or the channel's application itself. This is where we're going to get into that background workers. So let's talk about background workers. This is where we're really going to focus the last part of this talk, because that's actually what's important for us. We want on start for our application to be able to start up and establish a WebSocket connection to some other service, as opposed to a browser starting up and establishing a connection to our application. We are basically becoming the client, but it's kind of hard to talk about clients and servers when it's bidirectional. But in our case, the integrations for Discord happen over WebSockets. So if I actually want to write, if anyone's ever written a Discord bot, oh, thanks Alexa. I don't think I need any help. She's actually searching for Discord integrations and helping me out. I don't need that. I'm good. Got this. The Discord bot is written as a WebSocket integration. So if you want to write your own Discord bot, you typically have to run a server or service someplace that connects to Discord over a WebSocket, and you then subscribe to various messages. So we need to do the same from our Django application. And the reason we want to do it inside of our Django application is we want to be able to leverage things like the data we have in our app, like what channels to log into, what subjects to listen for. We can store those things inside of our database and use the Django ORM to be able to talk to all that data, as opposed to having to write another service sitting outside of our Django application. So we're going to talk about how we can actually turn the Django channels, in kind of in reverse. We really want the reverse of what we've been doing, which is like a web browser connecting to our app. We want our app to go talk to another app someplace else, kind of a more machine to machine type application. But it's still going to be we're going to establish that bi-directional channel for our app and have that as being like a long running service. So we're going to take that background worker, which normally is kicked off by some kind of event inside of channels. You can think about, one second. As an example application for using a background worker in channels, if you had a photo sharing site and you wanted to be able to generate thumbnails, you typically would upload photos into a site like that, but you wouldn't want to synchronously generate those thumbnails. You'd want to have some kind of a background worker do those things in, obviously in the background, because you don't want to block the next requests coming in from getting those photos by the fact you've got a worker stuck, generating and crunching bits by resizing photos or generating thumbnails. So you could have an upload into your Django app, kick off a message on a channel protocol saying generate thumbnails, and it can look for work to go do all that work. And at that point, then you've got a background task that runs through and does all of its work asynchronously as part of the asynchronous event loop, as opposed to the synchronous event loop, which is like the more request response loop. This now runs in the background.
Kevin,
yeah.
The workers are actually run normally as a separate process from the Django protocol server.
Oh, that's
so
right.
from the process that handles the incoming connections for clients, so that if you're doing something heavy duty, you won't block your Django application and slow it down.
Right. So
it's run as a managed.py run worker kind of thing.
Yeah, and they talk to each other over that channel layer. So that middle section of like what makes up channels, that channel layer, that sending of a message goes onto the channel layer, and like Peter just said, you can actually scale this out and have many workers listening for those messages coming across that channel layer. So yeah, and then you can actually scale it onto other machines and basically distribute that workload to other places while not affecting front-end web traffic coming into your Django application. So I'm glad you brought that up. So it does run in a separate process in an asynchronous loop. It doesn't affect your main serving of your site. So that's one thing you can do with a worker in channels. But we kind of want the opposite. Like, we're not going to kick off, there's not an event that triggers our channel protocol to kick off and do some work. We really want the thing to start up on start. So we want to, this is again why we want to use the channel background workers for this, is because we want to listen for these messages on the channel layer and do some work. They're very fast, very light, very easy to basically code. Kind of a little less to think about if you're doing like Celery, for example. You're not running a bunch of extra processes, and it's a little less heavyweight stuff going on there. Now, there are some caveats. The biggest one being that any jobs you send on that channel layer are an at most once operation. You're not guaranteed one-time delivery. You're at least guaranteed you shouldn't get more than once delivery, but you're all kind of also saying, well, it can be kind of lossy, possibly. When in the case for chat messages, generally not too big a deal. If it doesn't catch it on the first one, a subsequent message could resend all the data needed down the pipe. So you have to make sure that your application can handle that concept of an at most once operation.
I will say that I've never actually seen channels drop a message. It's only that under extreme load that it doesn't guarantee that.
Right. I haven't either. Maybe that's just more of a CYA by the authors of channels. If you're building your enterprise application and depending on a guaranteed one-time delivery, you might want to look at other tools that actually guarantee one-time delivery. But for our use case, this worked out really well. So, and speaking of our real-world use case, is we did want to write a Discord chatbot, but build it inside of Django so we have access to all the ORM and all the data of our application, so we can now interact with our application directly to a Discord chat room. And see, yeah, exactly. That was the main bit there. So let's hack our own worker. This actually, we were trying to figure out how to get these things to kick off on their own, like at Django start time, have it start up this worker and have it do some work without having to get a channel message first. With our 24 hours of innovation, I think I went to bed at like 2 or 3 in the morning, and Peter luckily is a few hours ahead of me in time zones. I woke up the next morning and Peter's like, I figured it out. I hacked the channel workers and made my own worker that does the work by collecting all the types of tasks you would want done and starts them up on start of your application. So this is basically something that channels can do really well, but doesn't do out of the box. I'll talk about that here in a second as we look at our implementation of our own run worker. So if you start digging in on channels and building your own channel protocol application, you'll run them with the run worker command from channels, but it will require you to send a message to it to get it started. In our case, we wanted it to look for tasks to do to start off with and kick those off right when I start running my process. So this is just a quick modification to one of the methods from the default worker. So everything else about mostly the default run worker from channels is the same, except when it kicks off this asynchronous handle, we go through collecting like, I guess, just asynchronous tasks that should be kicked off right away. There's some opportunity here for us to look at other tasks that could be kind of one time, like one and done, or long running tasks can all be collected together and then handled at the start of our specific worker.
The only difference between the standard handle method and
Way.
ours is the add coroutine line. It's the lackeys append SAs go,
Yeah.
the outgoing connection line.
Oh, right here.
Yeah.
Yes. Yeah. So really adding in that ability to start up those outgoing connections right away, because otherwise something has to do it for us. We didn't want to didn't want to have a hack in there to kick something off. Then you run into race conditions. We felt like this was a better way to go about it. So that's kind of like, why would we do that? Why don't we just respond to a channel error message? Is because we really wanted to be able to turn that concept inside out and have a long running process, a task that starts up right away as we start our application. So we talk about our example specifically is we receive messages from our Discord server. So if you're in a Discord channel on a Discord server, we want to be able to handle those just like we would have handled WebSocket events coming from, I'm sorry, not WebSocket events, the webhook events coming from our Slack integration. But in this case, we have to wait for WebSocket messages to come through. So we have a chat client, and this chat client's actually shared amongst all the workers that would be running in our application. They all start up on launch, and they just sit and listen for messages. And so they will receive, a payload. We will then turn that into a dictionary. And right now what we do is we kind of basically backdoor that operation into our existing infrastructure inside the application, because we were looking for webhook transactions coming from Slack. We just take that data and form it into a way that's already compatible with our application. This is kind of the quickest way to get it into the app. We're currently refactoring this a little bit to make it a little more specific for the Discord operation, but being able to actually shoehorn this in quickly, this worked out really, really well and actually made for a nice demo the next day. So that's for receiving messages. So our Discord client is just like a consumer. When a message comes in, it handles it, and basically fires off an asynchronous call to make the webhook transaction inside the database, because we don't want to tie up our worker doing synchronous operations to the database. And then if we want to generate notifications, like we want to do the other way, we want to send a message to Discord from our application. We have a consumer that listens for our channel messages. That was why I showed in that routing earlier on, is we have a channel protocol set up, and we have a message type, called send to Discord. And when you send a message on the channel layer called send to Discord, it then calls this asynchronous method of our consumer, and then it does all the magic to get the Discord client, get the right channel that it's supposed to post into, and then it does an asynchronous send on the WebSocket that we're currently connected to from our Django application, not the web browser. And so in our case, we actually have two sets of WebSockets going on. There's WebSockets connecting to the browser and WebSockets connecting to Discord, and they're all being managed simultaneously by our Django application and these run workers that we created to be able to handle the WebSocket application part. And then when you want to send, so from any task inside of Django itself, you can now do a channel layer send. So that's how we send a message onto that channel layer called Discord send. That matches up to what message is looking for over here, and of type send to
What was
Discord.
mapped in the setup?
Yeah,
Yeah.
yeah, this right here is send to Discord, and then we basically stuff our message in there. It's really nice. I find this to be really clean and elegant. I don't know how others have solved this kind of a problem. I feel like the channels folks, I don't know if they were thinking about using it this way, but it really, really works well for the other side of having our server send messages down a WebSocket to some other persistent connection that it connected to on startup.
The other thing about this channel layer thing is that it's not specific to Python necessarily. You could write a channel layer client in any language you want, as long as it can talk to Redis in the right way. And
Yeah.
people who've done this for like ham radio protocols and other things like that, MQTT, like that.
It's pretty crazy. And so yeah, and this technique not only works for doing WebSockets, but you could do like Peter just said, MQTT or packet radio, transmission, anything that needs to be listening, asynchronously to some source of data or sending data out to some other area is a perfect candidate for running these kinds of tasks. That thumbnail generation was a good example of this as well. But anything can be done now asynchronously as a long running task, and now you're not having to install and use Celery and Celery workers and kind of all the heavy machinery of Celery. Now, I'm not saying it should completely replace Celery. We still do use Celery in our application for various kinds of asynchronous tasks, but technically Celery still runs things synchronously once it gets over to Celery. This is a fully asynchronous solution, which is quite nice. Now, there are some things we want to do. We want to get this added to the channel's code base. Right now, you still do need to override and create your own run worker to do exactly what we just did. We want to be able to put in place some nice code examples in the documentation to show examples of like the long running or the single shot coroutines. So maybe you've got some on start type things you always want to happen whenever a worker starts up. And maybe you've got some types of tasks that are just literally connect to a long running service and maintain that connection through the lifetime of the process. And we want to add in the options for those two kind of classifications of coroutines, the ones that start right away or ones that do cleanup, ones that'll run after those stop. So you kind of can order some dependencies of your tasks and have a little control over that for how they run. Is there anything else we want to add onto our wish list, Peter?
I don't think so. It's a bit of a list.
It looks short, but there's a little bit of work still involved. But we're working toward getting those all implemented, and hopefully we can get that upstreamed, or at least made into a Django app like add-on that you could install into your application right alongside channels until maybe they upstream this functionality into the channels app itself.
An extension of an extension of
Yeah,
Django. Yeah.
right. Kind of meta, but it's extension of an extension. Now, one thing that there's obviously bumps when you go and push these things into production. There's something about channels that I'm surprised is not in the docs, and maybe we need to put a pull request in for this as well. But the channel layer capacity. So when you're running that Redis channel layer as your messaging bus, it defaults to 100. So if you have more than 100 messages pushed into that channel layer at a time as you scale up your application, they will drop silently. And Peter and I both scoured the docs and couldn't find it. We had to basically search the code, and I think you found it in a bug tracker someplace where
Yeah,
the maintainers were mentioning specifically this kind of default capacity. We have pushed ours up to what, like 5,000,
1,000.
1,000.
Is it
Yeah,
5,000 now? Might be. I don't know.
it might have been 5,000, but basically it just says we're allowing more to kind of trickle into our Redis queue, which Redis can handle a heck of a lot of stuff before it gets anywhere near falling over. So I think it's pretty safe to push that default up. That's just set as a um, in your settings file. That's right. It's in the settings file as an environment variable.
Yep.
Yeah, that's what I thought. So that's kind of like our one big trick and tip to anyone who wants to use channels in production is you want to make sure that as you go to production, you test it and load test it and ensure you're not going to run into issues with messages dropping silently. Well, I want to thank you all for coming today and listening to our talk about how to have fun and profit from abusing channels in Django. Any questions? I'm happy to take questions, and we can kind of jump in and talk a little bit about implementation or what we did. The Discord integration is releasing this month, I believe, for our product. So I'm pretty excited to actually see it go into production and have some customers actually use Discord instead of just Slack.
I have a question.
Yes.
Why not make a change so that things don't drop silently if that number goes above 100?
That's within channels itself. It's not something. It's part of the design of channels. Unfortunately.
I don't
Ow.
know if they're doing that like kind of a leaky bucket type queue, like to throttle the connections. We didn't look into it too deep because we're like, oh, set it to 5,000 and let's roll. I wish I had a more scientific answer for that one for you. I'm assuming that's what it's about.
Yeah, and Andrew Godwin is the author of channels, by the way. So he's the same guy that has written all the migrations and the asynchronous views and all that kind of stuff in Django. So he's one of the experts, I guess you could say. So
And he will be at the Python Web Conference as well. So if you all have not registered for the Python Web Conference is coming up in March 22nd to the 26th. He'll be one of the speakers. He'll be hanging out in our Slack, answering questions. So we could ask him then.
very affable fellow.
He is super nice. Oh my gosh, the Django community is full of amazing people. Like they're all very approachable, very easy to ask questions. I really have enjoyed being a member of the Django community.
Hey, Kevin, you
Yes.
mentioned one of the whys you did the Discord WebSocket integration from the channels layer was accessing specific database data from your own internal database. Was the amount of data throughput that you wanted back and forth a higher burden than you would want on the client side, like having your client side code connect to both your channel layer and the Discord channel layer from the browser? Like have a whatever JSON blob of you needed from your database preloaded and then synchronize that to Discord. I guess was a reason why you do it all client side.
Well, we did it all on this. Like all that interaction happens on the server, like in the Django application itself. It's really there's two separate operations there, and we wanted to keep them decoupled, like because the chat box is using the same code whether it's Slack or Discord. It didn't matter. It just has its own WebSocket channel that it talks to, and then it's a complete. I say it's a really decoupled process. It just felt cleaner that way to keep the two of them separate from one another. I don't know how we would even like accomplish that in the same like WebSocket channels layer stuff.
On the thing you can't in the Slack box, or what we call the Slack box in LoudSwarm, you can't send messages to the channel. It only receives messages from the channel.
Currently.
So it's, yeah.
Oh, actually, no, that's not true. We authenticate users over the WebSocket as well. So it does receive
No,
a message.
what I mean is you can't type messages and have
Slack
them send,
messages, yeah.
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 So it's basically just receiving the messages and throwing them onto the screen so you can keep track of it while you're watching the session.
Does that answer your question, James? I'm not sure if it does.
And maybe I lack the understanding of WebSockets from the browser. Maybe you can't subscribe to 2 different WebSockets from the browser at the same time to
Oh,
do.
you totally could. The reason we don't have the browser talk to Discord directly is we want to be able. There's some keys and authentication to Discord for our app. So our app is registered as a bot in Discord, and so you have to have a long running process that maintains that connection to Discord to be able to interact with Discord. So you can't from a browser have a I don't know how you'd even do that. I don't think it's even possible. Is you really need to have some kind of centralized spot where your bot runs, and your bot can be sharded across many different servers that are running your app, but it's all running the same code and it's all responding to the same messages. And so it's the one conduit into our application is that one single point. Well, a single point that can be load balanced.
Plus, you don't have to actually be a Discord user to receive the Discord messages when you're seeing them in the channel.
That's true too. Yeah, you don't have to even be a Discord or Slack user to actually see all the messages coming into our WebSockets to your browser.